Good morning, everyone, and welcome to the first session of the day. With us today is Alexander Garcia. He's going to be taking us through quite a journey, an odyssey from FAIR to the mesh. So, Alexander, without further ado, I'm going to put your presentation on screen. It's a great pleasure to have you, and the floor is yours.
Pleasure is all mine. Thank you very much. And actually, thank you very much for the invitation. When I received your invitation, I have to say that I started to think what could be interesting, what could be interesting to tell that could lead to some interesting discussion, but also that could lead to some interesting takeaways. And then I realized that in our data integration journey, it was mostly a data integration journey, a standard data integration journey that had two components. It had graphs all over the place, but it also had a lot of devils. And then I started to put things together in my mind, and I realized that this was something I had been writing about in LinkedIn, which is how the data mesh, the journey, your data mesh journey, is somehow related to a fair data journey. And I started to do some research, and the two concepts, data mesh and fair data, have not really been well explained how they come together, and that's how I put together this presentation. So let me just start by saying that. Saying that. How can I do? Okay. Okay, so let me just describe my agenda here. Is very simple. So I'm going to talk about the journey we're taking into our data integration effort, how we are using FAIR, the FAIR data concept, to pave the way, and some of the FAIR data principles, of course. And then I'm going to talk about how FAIR and data mesh come together. So how all roads lead to Rome. And then I will just go ahead and try to discuss some of the lessons learned and some key points on how to keep moving forward. So our simple journey. Let me just start by saying that I work in Siemens Energy, and we in my organization within Siemens Energy, we are responsible basically for integrating data. And we integrate data across heterogeneous data models. So right now we have integrated more than 28 different data models. Those data models come from different tools. Those tools are being used, are common software tools that people use to support the execution of projects. So if we're going to be building a very large power plant, so this is the kind of software that will allow you to do procurement, to do logistics, to do engineering, design engineering, etc., all the way through the point in which everything is inside and things are being built. Actually, civil engineering, pretty much. And this is of course, you can imagine through the execution of these kind of projects, you generate a lot of data. And because this data comes from a very complex tool landscape, more than 100 tools, and you always need, if you want to do proper project management, if you want to be precise in how you are doing project management, you have to have access to unified views on the data. So that's more or less how we started to exist, to integrating data during the execution of a project. So this is also leads to, inevitably, once you start integrating data, you have to understand what business processes is data involved in. What kind of tools are part of those processes? What people are part of those processes? What data is being moved back and forth through those processes? And that's how we support the execution of projects. So just summarizing, it's a very heterogeneous landscape. It's a very tool complex landscape. It's very data intensive. And it is a very interesting area because it really is about supporting business cases. So we are not supporting heterogeneous data integration in an abstract way, but we are focusing on specific issues that come when you have to monitor the execution of very large projects. Our approach is very simple, and I don't need to go a lot over this. I mean, we are basically taking data ingestion and extraction from many different heterogeneous data sources, many different applications that interact with each other at different points during the execution of very large projects. This is common across many industries. It's not just for this specific industry. We do this data onboarding, we do a lot of data cleaning, we do a lot of data wrangling, and then we do this interesting part, which is the semantification. We add semantics to the data. When we add semantics to the data, certainly at that point, after we have gone through all the data wrangling, data cleaning, etc., then what we have is some kind of fair data. Some of the aspects in fair data, the principles in fair data, at that point are met in that point in the execution of our integration approach. Once we have that data in the graph, then we deploy that. And we deploy a knowledge graph for our use cases. And then at that point, the data is machine readable and reusable. The data is annotated with semantics so that the data is very interoperable. I would say highly interoperable. Certainly a different quality standard from the one we started with. And then once we have that enterprise knowledge graph, because in reality we are building an enterprise knowledge graph, we have an application layer, and the application layer is just where this integrated actionable data is being deployed so that it can be further reused. How is it being further reused? Well, we can use it in Tableau dashboard, BI dashboards. We can use it to exchange data across tools. I mean, whatever data use case we have at hand, we support that over this application layer. Our journey is very simple. In reality, I cannot underestimate the power of simplicity because here you will see it through my presentation. So we focus on business cases, and we do business cases are basically use cases that come that need data integration that arise during the execution of a project. So a project manager approaches us and say, you know, guys, I need to integrate data from scheduling into logistics and from logistics in procurement. And then we take a look at that kind of processes. We take a look at how processes are related to data, how that is related to tools, and where is people in the equation. Of course, when we are doing that kind of analysis, we have to go through extensive analysis in data quality, because when we are ingesting data, all of the issues that you can imagine related to data quality come up. And then, not least important here, I want to emphasize that we focus very much and have very clear requirements and success criteria, because we don't want to have endless loops where we are responsible for the data integration. We are a solution provider, basically. And then we don't have a clear understanding as to when do we have a point in which we can say, okay, this is what we agreed on, and here you go. I mean, if anything else we need to support, then we need to understand it as a different project or different use case. Of course, our approach is very semantically driven, and then we have a lot of ontologies. And when it comes to ontologies, I have to say that our journey has been a journey on its own when it comes to ontology management, because we have now in place some kind of semantic integration plugin mechanism by means of which, whenever we have new tools, then we are capable of integrating those new tools from the ontology perspective. We have done a lot of standardization in what has to do with ontologies. We have understood how to measure the quality of the ontologies from a very pragmatical point of view, so that this quality is related to our capacity to support this semantic integration plugin mechanism. We always follow this KEYS philosophy, which is keep it simple, stupid, and this KEYS philosophy gives us a sense of pragmatism, because our ontologies are very pragmatical. Our ontologies are not overly complicated. And I think that in this sense, I would say that I want to congratulate you guys at Semantic Arts, because your upper level ontology is an example of a very pragmatic upper level ontology. We do the ETL, and then we certainly do a deployment in the graph. Once we do the deployment in the graph, before building Tableau dashboards or before considering that this is done deal, We go through extensive graph visualization and analysis of the data with data owners, with product owners, with stakeholders, etc. And this is because once you look at the data in the graph, once you understand how the data is interoperable with other data sets that you were not considering initially, most likely you will immediately realize that you could probably benefit from integrating other datasets, from expanding your very narrowed view on your need for data integration into something much wider. And that's where having this kind of visualization of the data in the graph helps us a lot, particularly with business owners. What we do in the execution of very large projects is that the execution of very large projects is always generating a lot of different a lot of documents, basically. So this moves from a document being a document-centric operation where at any given point through the execution, any given phase or stage, you're generating documents, right? Whether they are Excel spreadsheets, whether they are PDFs or PowerPoint presentation, anything. I mean, this is a document-driven operation, and we want to move from a document-driven operation into a more data-driven operation. And then what happens when you have a lot of documents? Well, you have a bunch of documents, but you're basically having a data set that is very labor intensive, that is difficult to search, it's very prone to errors. Doesn't make it easy for you to do track and trace, and that makes it difficult for you to automate processes, make it difficult for you to get out of that data pool real actionable data, things that you can work on. So there are lots of issues there. And what we do, our approach, what is a data-driven approach for us, is that instead of moving from documents, we are moving from data. So we are looking at this aggregation as an aggregation of data and not so much an aggregation of documents. Once we take this approach, then you are moving into an area which is very knowledge intensive. And here is where ontologies come in this whole picture. How is FAIR paving the way? Ontology certainly, but how is FAIR paving the way? I mean, our vision in becoming a data-driven company, as I said before, moving from simple documents into more of a data-driven approach for managing project execution and doing data integration in the execution of large projects, goes through ontologies. But then we realized that just ontologies was not enough. I mean, there were quite a few things missing. And then the 4 axes for FAIR, findable, accessible, interoperable, and reusable, within a proper data management framework, that's how we started to understand that we could conceptualize and build, further build our approach. So in here you have findability because you are actually using an ambiguous identifiers and the standard descriptors. You have accessibility at all levels, so you somehow standardize the way APIs are providing that kind of access. You have a very high quality connectivity tissue because you have high quality ontologies, but by high quality ontologies, I mean pragmatically built. And you also, but once you meet F, A, and I, you are basically in the land of reusability. You have highly reusable data. And when we started to go further into that, and then we started to look at more data qualities, data criteria, KPIs that we should meet in order to be findable, accessible, interoperable, and reusable. And this is a point in which I can see that the whole FAIR thing needs to be more, or I would say the FAIR work needs also to go very deep into data quality and data governance. And those are perhaps 2 topics that if FAIR, the whole FAIR thing meets, it would make it much easier for enterprise data efforts to really adopt the whole approach. So we are, as I said, we are incrementally aggregating different data sources, and of course the documents are continue to be generated. But as we see this from the point of view of data, we are really aggregating data. And our ontologies are not ontologies that live in isolation. So we are always considering how is an ontology related to another ontology. So reusability of ontologies is key for us. And therefore, standardization in the way we build ontologies is also a key topic for us. By way of doing that, I mean, it's not that we are replacing the way people work. We are not forcing anyone to work in a different way. What we are doing really is to get out of those documents the data that we need so that we can support the same kind of aggregation that people do in their minds and in their way of working with respect to documents, that we support that from the data perspective, from the data angle. In our business, we have to integrate. I mean, data integration and data efforts are very influenced by the standards that are industry standards. And some of those standards are like, for instance, the ISO 81346. And 81346 is a very nice standard. It gives you a very nice conceptualization or way of thinking so that you can organize your data according to function, location, and product. So those are the three aspects that this 81346 embraces. And if you consider that, then you will see how those aspects, once you understand how to work with them, once you understand how to implement and, sorry. How you understand how to implement them in your data enterprise environment, and you will understand that they give you a way so that things can be plugged together. Because at the end of the day, what you want to have with ontologies, and ontologies are very important when you're building an enterprise knowledge graph and when you're moving into this FAIR approach, but also when you're moving into building a data mesh, and I will go on that in a moment. Because what you're doing with ontologies is that you have reusable bricks. You're standardizing one aspect of data, the semantic part, so that you have reusable bricks. And reusable means that you can repurpose those bricks in whatever way you want to build whatever figure you want to build. At the end of the day, what you have is machine integratable models. Those machine integratable models are supporting the aggregation, the aggregative nature of data integration. When it comes to ontologies and terminological resources, I think that there is a lot of need from companies to really understand what it means, and also to make it clear, a clear distinction between the so-called business glossaries in the data catalog, managing lineage in the data catalog, and the part that has to do with enterprise data models and terminological resources are part of enterprise data models. You need to standardize that, and you need to do that with people who really understand about ontologies, but also with people who do really understand the business processes, the different the business terminologies that you ought to standardize along the way. The product ontologies, the way we see it, is basically around 4 building blocks. So one is interoperability. The other one is core ontologies. We do have core ontologies, but not core ontologies in the sense that we have one single upper level ontology and then you have the main ontology. No, not that so-called traditional, I would say very academic core ontology view. Our is a little bit more pragmatical. We have standardized the annotation properties. We have standardized object and data type properties. We also have clear guidelines as to how to name things, so that whenever you need to reuse, you know why, how, and why, and how to reuse across different ontologies. We also have to consider the toolkit that you need to build ontologies. It's not just about having one single ontology editor, whether it's Vertige, WebVertige, or MetaFats, or Top Rate Composer, I mean, whatever, you name it. There are many in the market. But it's not, the ontology editor is an important component in this toolkit when you talk about an ontology management framework, but it's not the only one. And last but not least, something that is often left behind is the community building part. Community building, data domains, they go hand by hand, because ontologies have a huge impact in specific data domains when you are going through this data mesh journey. And when you look at the way you should facilitate the shaping up of communities of practice, you will immediately realize that data quality in what has to do with semantics, but also in the way the data is modeled for enterprise data modeling, that is rooted in the data domains themselves. And that expertise is there in the data domains. So community building is something that you should do hand by hand with your data architecture. What do we consider here very important? People, skills, processes. You need to be able to have clear processes when it comes to supporting the development of ontologies. And you need to establish a relation between tools, processes, and people. And of course, skills is not something that you can forget about. But always when you're building these ontologies within the context of an enterprise knowledge graph, I mean, you have to make it, or we have seen that it is very important to make clear what is the value proposition. Why are you doing that? Because building ontologies takes a lot of time. Whatever you can automate now with by means of LLM that minimizes the need to interact with domain experts, go for it because it will pay off incredibly nicely. The other thing that we have seen is that don't depend so much on people's expertise for building ontologies. Go for the actual data schemas themselves, because at the end of the day, most of what you need is there. Um, do all roads lead to Rome? And if we consider the point, our end game, fair data, I don't think that fair data just on its own is enough. You need to orchestrate data governance. You need to orchestrate business processes. You need to keep an eye on identifiers, and these are very industry specific. The problem with identifiers in industry, for instance, reference designation systems, is that they leave a lot of space for interpretation. That defeats the purpose of a standard. This is a problem that I have seen also with ISO standards. You have issues around data quality that you need to align with your overall fair strategy, if you will. Last but not least, of course, you need to align. I mean, fair is part of the data architecture, and you need to align them. Where is the melting point? Across domains. It's data integration across domains, because that's ultimately what you want to achieve. Fairing the mesh. I mean, if you are going for data mesh. Sorry. Ahora en media hora. Dame I'm sorry, guys, but my daughter is sick, and anyway. So if you want to fair the mesh, if you're going through this data mesh journey and you're going through this fair journey, align them together. And align them together in every sense of what an alignment means. But here is one important thing. We know and we understand that data products are very important in the whole build up of a data mesh architecture. But what is the quantum unit in fair data? I mean, we know that the data mesh introduces the concept of data product, and that is pretty much the architectural quantum of data mesh. In the fair data conceptualization and all fair data theory, I would say that it is ontologies and metadata management where you could find this quantum unit. But you need to look deeper into that, because that's really a key part of this so-called alignment. Moving forward, what do we see moving forward? Fair makes sense. Makes sense because it makes it very easy for you to explain something that otherwise would be very complex to explain. It also helps you to focus on things that are easily measurable and that have a real impact in business. Like, for instance, how you go about finding data, right? It's an easy one. Data mesh makes complete sense. I'm a practitioner and I'm all for it. But you have to understand that data mesh is not a data management plan. And the worst thing that you can do is to start selling enterprise-wide data mesh as just a data management plan. That's not what data mesh is about. Understand that you need to sell this, right? At least the way I see it, you need to start making the case for the value of the data. And you need to understand the data mesh. The way I understand it is more as an operating system for data. is and here I like the latest concept being brought by data mesh, which is an autonomous data product. That is that if you read that kind of conceptualization, if you read the theory behind the data mesh, that will help you to understand how to best explain what is the data value proposition. Why is it that I insist so much on data value proposition? Because I feel that there is a big gap between investments in data and returns of investments, right? If the investment in data doesn't go hand by hand with with the with the understanding a company has about the value proposition, the value in data, then it's going to be very hard to explain how these two are related to each other. So sorry, fair, yes, but I would say fair with a real clear business purpose. What lessons have I learned? Have a clear end game from the beginning. You need to explain what's the end game. You're not building a bridge to nowhere, and you have to be clear as to what is the landing port of that bridge you're building. You have to focus also on building capacity. Why? This is a transition. For many companies, this whole data thing is new. And understanding how data is a valuable asset, an asset on its own, for a company that is probably not selling data or not selling data services, that's not easy. So you have to be patient in supporting that transition, but you also have to be relentless in building that capacity, in supporting the communities of practices, in implementing things for which there is a clear value proposition. Last but not least, I would say that, for instance, in my industry, it is very important to start working on a community basis across industries in what I would say are community assets. There are many ISO standards, and people love ISO standards. I particularly don't like them so much because they are just PDFs. It's not like when I have a W3 standard that is something that I know how to use in software. When I have an ISO standard, it's not so clear to me. But anyway, understand that you need to go for community assets. You need to build that, and it's not difficult to explain. Look at pharma; they have a SNOMED, they have communities like OMOP, they have FEAR, they have they have lots of different vocabularies to tap in, lots of different standards, and that was not coming out of the blue. That was a concerted, well-coordinated effort between academia and industry. That's why when I was working in life sciences, for me, it was very easy to say, well, it was not very easy, but I could say with some confidence, okay, it's going to take us like 6 months to get an ontologist, but we will get it. In this industry, it's completely different because you don't have that coordination between industry and academia. And you don't have that understanding of what is a community asset and how participating in this kind of community efforts is in the best interest for your company, because it will make it possible for you. Once you enjoy the benefits of data standards, you can establish automated relations with your providers, for instance, with your suppliers. You can do better supply chain management. All of that is not theoretical. All of that is real. And I think that is part of the challenge. So with that, I want to finish it, and I want to thank you all for having me invited into your sessions.
Alexander, thank you very much for taking the time to step in and share this wonderful knowledge with us. It's deceptively nutrient dense. There's a lot to take away from this presentation. So we have some questions that are piling up here in the chat, and we're going to start with Steve. We're a little biased, so we're going to take preference for him to start. But can you further describe how Siemens Energy determines the quality of the ontology model?
We have an ontology quality framework that is basically measuring how the ontology, first of all, competency questions. Ontologies have to meet the needs of competency questions. The competency questions are not just derived from scenarios of use. Competency questions are also, they have to be you have to be able to express it in a Sparkle, yes, but you have also, and this is part of our quality take, you should also make sure that once you have the data in the graph, then whatever use case needs to be supported consuming the data so that a Tableau dashboard can represent something, that is also met. So another aspect of quality here has to do with the standardization of annotation properties, object properties, and data type properties. With the I don't like to say enforcement of reuse, but strong advice on reusing when possible. Another aspect for us that is very important has to do with always, always have a strong engagement with the community behind those use cases, and have that community understanding their ontologies, right?
So functionally fit for use. Do you have a spectrum of how fair it is, and how it can hook up and play nice with the other interdepartmental or
Yeah,
interorganizational pieces, right?
yeah, correct.
Okay, so this is directly tied to that. Peter Winstanley is
But
sharing.
we are not religious on ontologies. I wanna be clear on that, right? I mean, ontologies are part of software, and at the end of the day, I care about satisfying the need.
Business requirement, the functional requirement. Yes. Yeah, no, that's what has allowed this to spread so quickly, that it's pragmatic, right? You're just implementing what works, and then when you have a chance, you tie everything together, but the opportunity is land and expand, right?
And ontologies evolve. I mean, we have to build clean, fast and dirty ontologies, and then as we go along, we improve them. But we don't pretend to go for the perfect thing in just one go.
Understood. And Peter, he's sharing a resource here, cross domain interoperability framework. So this is right aligned with that fair data mesh architecture and blueprint that you were sharing with us through the journey, right?
If you could share with me, or I don't know if I will have access to this later, if you could just drop me an email with that, I would really love to take a look at this. Yeah.
You betcha. Um, Here's a comment from Peter Campbell. Hi, Alexander. I worked for over 5 years in high power transmission, which relies mostly on IEC CIM standards. How do you harvest these structures? And can you easily turn these into ontologies? These cover diverse aspects for data interoperability, including assets and more dynamic information.
The answer is no. It is not easy to transform that into ontologies, because I think that the purpose of those ISO standards was never to have ontologies or to support data interoperability. How do you go about doing that? You have many different techniques, and ontology engineering has techniques and tools to do that, to support that. There is a little bit of manual effort. We are also using LLM technology so that we can harvest the terminology. But at the end of the day, this one, there are two sources of truth, as I call them. One is the data. That is the reality of your company, the data schemas that are supporting your operations, because those are really where you can find
That's
most.
reality. That's where you're storing everything as it stands today.
Yeah. And you have some validations from business experts, stakeholders. Stakeholder validation is also important.
Okay. And I hear you what you're saying with ISO standards. They're obfuscated and they're like very high level, and they don't have the implementation pieces baked into it. So it's
No,
a little bit fuzzy of an area.
actually, I have to say that reference designation systems, for instance, they are key in this kind of industries. I mean, not just for us, but for many other industries. And interestingly, you don't have that kind of reference designation systems, even though they are publicly available. Most of them, they are not available as ontologies. Now, there is an interesting effort which will be launched in a few weeks. That is a community working group under the W3 umbrella, that has the scope of precisely addressing this issue of transforming reference designation systems into ontologies and have them available for everybody to adapt or to take. If somebody wants to know more about that, just drop me an email. Please, Joaquin, feel free to share my email. I'll be very happy to discuss that privately with those who are interested in this.
Or I would advise people to connect with you via LinkedIn, and from there you can.
Yeah, sure. Yeah, I mean, this is something I'm very interested in seeing happening. Yeah.
We have a question here from Steve. Do you have any concrete examples on how the use of ontologies have provided true business value, speed to market, ROI, or interoperability? I know a lot of the examples that you were painting were how do you trace the movement of raw materials throughout the supply chain to the final product, the management of the project management schedule, and then like projecting who's working on what, where, and why, right?
Yeah, that's one kind of examples. Another example that comes to my mind with clear return of investment is supporting the detection of issues. In this industry, we call it non-conformances. So detecting and classifying those and assigning priorities to those is something that needs to have clean data. It's not just ontologies, and I want to emphasize it's not the ontology, it's not the magic one, the one and only
That's an
thing.
enabler. That's an enabler. That's an
It's an enabler,
yeah,
and that will make your machine learning models more accurate.
structured.
That will also make your LLM efforts much more clean in the responses you get from them. And yeah, I mean those are, but that one, the issue compliance is also another example. Legal compliance, like for instance, carbon footprint, which is coming across all industries, is another example where semantics play a key role. And it's something easy to measure because you can measure the time that you spend having those reports being sent over to the European Union, showing that you are compliant, or just track and tracing your carbon footprint for any given product, because you have to integrate data, I mean, from many different areas. And then that integration, what is the first thing that happens when you're integrating data? Data quality, man. I mean, a project here is defined in a way that is incompatible with the way a project is defined here.
Right.
We're maybe talking about the same product here and here, but it happens that we are using different words, right? So that is something that your terminological resources slash ontology layer should resolve. That
Right.
resolves quickly, and then you can move on. So that's easy to measure it.
We have a question from Chris Harding. Thanks for the excellent presentation. Do you see data mesh as being a mesh of independent knowledge graphs or a single knowledge graph with a mesh of subgraphs? That's a good question.
I think that in both FAIR and data mesh, that knowledge graphs are not explicitly mentioned. But I would argue, based on my experience, that the best way to implement data mesh, a data mesh architecture, it is by way of an enterprise knowledge graph. So that's how I see it.
You need
I
a
don't,
connectivity layer. You need something to orchestrate and federate, right?
because when you look at data domains, when you're building your data domains in a company, and then you have to go through all these endless discussions and etc. What I have seen is that at the end of the day, you have business objects, and those are related to ontologies. I mean, whether you like it or not, they are related to some terminology, some standard, some ontology. Once you establish that, what happens is that operationally speaking, what is it that you expect data domains to deliver? Data quality. And why do you want to deliver data quality? Because you want to facilitate data integration, right? Whether your value is seen as faster reporting, more accurate report, whatever. But at the end of the day, that's the core of it. So I would argue that, yeah, I mean, those are clear components. I mean, graph technology is a clear component in both FAIR and data mesh.
And I want to follow this just through my curiosity, but this data mesh is a shell of an implementation. It's an architectural practice, but the basis of it is the skills and operations of the individuals involved in enabling this kind of architecture, right? So, like, maybe if you have multiple teams, they have multiple knowledge graphs and they own them and then they federate with each other, right? That would determine the structure of the architecture.
Yeah.
Because it's not
Um,
always just the technical details unless it's centralized, right?
yeah, yeah, yeah. And as I said in one of my slides, I mean, this understanding that data mesh is a data management plan, I mean, forget it, man. I mean, I recommend anybody hiring a data architect. The first thing I would expect from a data architect is to have someone who is strong on the theory of data architectures, because that's what will allow that person to be flexible in how to implement it inside an organization.
I'm kind of mad that we're out of time and I'm going to violate one more minute, but I very much enjoy and agree with the sentiment that it's not just the absence of technical implementation, but you need a data governance, AI governance complement. It's both uh, right brain and left brain that are kind of merging together to make a useful solution, right?
Yeah, yeah.
All right.
AI, I think AI is quickly making that executive layers in companies become more conscious of the value of data.
Nobody cares about data for data's sake. People care about what data does. So
Yeah, it's true. So yeah, I mean, guys have more questions or?
no, there's one more from Steve. What kind of triple store or what kind of technologies tools have been useful in promoting fair?
I mean, in FAIR, it's funny. I, mean, I participated in the very early discussions of FAIR data. I remember some of those happened in Japan back in 2017 as part of these biohackathons in Japan, and I was there. Um, Even though that crowd, the biohackathon crowd, is very semantic, ontology driven. I mean, religiously ontology driven. I didn't see ontologies. I don't remember if ontologies are explicitly mentioned or graph technologies is explicitly mentioned in the FAIR principles. I think not. I think they refer to it as metadata or structured metadata and identifiers. Yeah. But I think it is clearly a part of a clear part of that.
Excellent. There's Andreas Newman, and he says he was working for Siemens Energy as well. I don't know if you've come across him, but
Yeah, sure. We are colleagues. We're still colleagues. So, well, actually, with Andreas, it is with whom we are somehow trying to bring people together into this idea of common assets, which I think is very important because if you really want to overcome many of the supply chain management issues, you need to standardize the way you name or the way you classify products. And you need to make it in a way so that you don't leave so much room for interpretation. But you also want to have this in a way so that the process is very agile. And this is part of my concerns with respect to ISO. ISO is somewhat close,
yeah,
not
it's
very transparent.
opaque. You got to pay for it. That's what Peter's saying.
You gotta pay for it, yeah, and it's not. Perhaps it's a generational thing, and probably it is a generational thing. But in any case, my take is that whether it's ISO or whatever, we need to have a better understanding of what are our community assets and ontologies or data models, whatever you want to call it, are part of our community assets. And it is in our best interest. I mean, because this is money. I mean, at the end of the day, once you have a grip on your supply chain management, once you have gone through all of this standardization, once you are able to track and trace something across your data infrastructure, you're saving money. It's either you're saving money or you are um, making it possible for somebody else to monetize on the data you are generating.
That's why we're in
So
employment. That's why we're building these things. We're being funded to create an ROI.
yeah,
Alexander, we went over 4 minutes. I deeply enjoyed it. I want to go another 30 minutes or more, but we have to cut it off here, and we're going to continue with the panel discussion. So everybody, stay tuned. We have about 2 to 3 minutes that we're going to take extra to prepare for the next presentation. But we'll be talking to you real soon. Thank you, Alexander.
Thank you. Take care.
Take care.